Hey everybody, hope you had a great day yesterday. Finishing up section 9.6. If you have any questions on that stuff, please either email me the question or email me to set up a Google Meet so we can discuss those topics. Today we're going to go back and do 9.1. So we skipped 9.1 in the hopes that we'd be able to do it in person. It doesn't look like that's going to be the case anymore, so we're going to go ahead and do 9.1. 9.1 is dealing with radicals and simplifying them. It's a pretty important topic that you need, especially in Algebra 2, because you need to write your answers in simplified radical form. So, if you have any questions on this, again, I'll have some open meets during the days that you can reach out to me then, or you can set up a private one if you want to go over things that you have more questions on. So let's get talking about it. So the product's property of square roots. What that's saying is that if you have the square root of, let's say, 45, that's basically what this is saying here. They're saying if you have the square root of 45, well, 45, you're looking for the biggest perfect square factor of 45. So perfect squares, remember, are like 4, 9, 16, 25, 36. Those are all perfect squares. So the greatest perfect square factor of 45 would be 9. So I can break this up into the square root of 9 times the square root of 5. That's basically what this example is saying here, that you can have 9 times 5 inside the radical sign, and then you can break it up into two separate radicals. So the square root of 9 is 3, and the square root of 5, I just keep it the square root of 5 because that's an irrational number, and so we leave it like that. That's in simplified radical form. So that's what we're going to be doing today. So for the next example here, we have the square root of 108. Now it might be helpful to you to write down the first 10 perfect squares, so you kind of just look at it and see which one is the greatest perfect square factor. Now I'm not going to choose the greatest perfect square factor here to show you that if you don't choose the greatest perfect square factor, you can still correct your error later in the problem. So the greatest perfect square factor of 108 is actually 36. But I'm going to pick 9 because I'm going to pretend that I didn't see that 36 goes into 108. So I'm going to separate it into the square root of 9 and the square root of 12. So the square root of 9 would be 3, so I'd have 3 square root of 12. Now, how can I see that I didn't pick the greatest perfect square factor? Well, you look what's left inside of the radical sign. If there's still a perfect square factor that goes into it, it means that I should have picked a bigger number, but I can still fix it from this point. So are there any perfect squares that go into 12? So remember again, perfect squares are 4, 9, 16. Obviously 16 is too big, so do 4 or 9 go into 12? Yeah, 4 does, right? So 4 goes into 12 3 times. So I'd have 3 square root of 4 square root of 3. Now these are all multiplying each other. It's just 3 times the square root of 4 times the square root of 3. What is the square root of 4? The square root of 4 is 2. So I have 3 times 2 square root of 3, which is 6 square root of 3. Now if I noticed that 36 was the biggest one, I would have right away gotten this as my answer. But it's okay, I can still get the answer from here. So with b here, now we have another interesting aspect of it. We have a variable on the inside. So it's the square root of 9x to the third. Well, we're going to look for perfect square factors. Well, 9 is definitely a perfect square, so I'm going to keep that in the perfect square radical sign. And then I have x to the third inside. So what I want to do, since I'm taking the square root, is you are going to be dividing the exponents by 2. So pretty much you want to take away all the even exponents. So since this is a 3, I'm going to put x squared in the perfect square radical, and I'm going to keep x in the non-perfect square radical. So the square root of 9x squared is 3x times the square root of x. So with our exponents, whenever it's odd, just take 1 away and put the 1 inside of the radical sign and keep all the even ones inside, whatever's left. And that's when you're taking the square root, because you're dividing the exponent by 2. So if this was a 5, you'd have x to the fourth here and x here. If this were a 6, you would just keep the whole x to the 6 here, and there would be nothing in the non-perfect square radical. All right. So now let's go to the next set of problems. If you could do these 4, please pause the screen so that you can try them on your own. And then in just a minute, I will play. When you press play, all the answers will be up there. All right, so here are the answers. I simplified the expressions. For number 1, the 4 was the greatest perfect square factor of 24, so square root of 4 square root of 6 becomes 2 square root of 6. 16 was the greatest square root factor, perfect square factor of 80. If you did 4 and 20, that's fine. Just notice that 4 goes into 20 again, so you'd have to do that one more time. So you should either way get the answer of -4 square root of 5. For 3, since we have an x cubed inside, I put x squared in the perfect square factor radical, and just x in the radical where it's going to stay there. So 7x square root of x is the answer for that one. And 75 n to the 5th. 25 is the greatest perfect square factor of 75. N to the 4th is what I'll take out of n to the 5th. And then 3n stays inside the radical. So I get 5n squared, square root of 3n. If you have any questions on this, again, please put them in the doc or ask me during the open meet session. Okay, and for the next thing we're going to learn today is the quotient property of square roots. This is basically just saying that if you're taking the square root of a fraction, you're taking the square root of the numerator and the denominator. Okay, we're going to learn also later that we can't leave a radical sign in the denominator. We have to rationalize the denominator, so that is something we'll also talk about. But in this case, the denominator is a perfect square, so the square root of 4 would be 2. So you get the square root of 3 over 2. So if you have a radical sign over a fraction, you take the, if it's a square root sign, you take the square root of the numerator and the square root of the denominator. Okay, so let's look at some examples. So if we look at A, the square root of 15 over 64 is the square root of 15 over the square root of 64. And does 15 have any perfect square factors? No. 4 doesn't go into it, 9 doesn't go into it, and 16 is too big. So at that point, it's not going to have any perfect square factors. The square root of 64 is 8. So that's our answer, square root of 15 over 8. For this one, the square root of 81 is 9. The square root of x squared is x. So 9 over x is our answer. All right. So if you're ready, try these 4 out. And when you are done, press play again. So pause the screen so you can do the 4. And then when you're ready, press play and look at the answers. Okay, so for number 5, we have the square root of 23 over 3. For 6, we have negative square root of 17 over 10. For 7, we have 6 over z. And for 8, I got 2x over 8, which then simplifies to x over 4. Please note that you can't simplify if it's inside of it. Let's say I had like the square root of 5 over 10. This in no way would become 1/2 because the square root of 5 is not really 5, so you can't simplify that. If there was something in front of the radical sign, if I had like 2 square root of 5 over 10, well then I can simplify the 2 and the 10. But again, the square root of 5 would stay the same. So if this were the case, I would get 1 square root of 5. I wouldn't even need to put the 1. I could just put the square root of 5 over 5. If this here was the case. But the square root of 5 has nothing to do with this. That would be my answer. Okay. All right, guys, and that's it for today. So at this point, please do the big ideas assignment. And if you have any questions, please either email me, write it on the Google Doc, or wait for the open meet. All right, guys, have a good day.